I'm Chantel Prat, and I'm going to talk to you about a program of research that was motivated by the collision of my personal life as I finally caved and tried to learn to program in Python in my 40s, and my professional life where I study individual differences in brain functioning, and I'm really interested in how people with different brains learn and think differently. And because I don't trust myself to get through the important parts of this talk in 5 minutes, I'm going to give you the takeaways up front. They are that we need better models of when, why, and for whom learning to code is hard. And also, I think there are some exciting opportunities for neuroscience and neuroscientists to make a contribution to the identified challenges in aptitude research. So the problem in a nutshell is that aptitude is supposed to measure how someone will perform in the future. But as it exists now, it primarily relies on measures of, I don't know why my slides aren't advancing, what somebody already knows. And if the tests aren't designed well, we can perpetuate systemic biases, especially as they are organized around access to resources. This infamous SAT question shows that a verbal analogy is really biased by people who have experience with things that are more related to socioeconomic status than probably the way you think. What we really need is something like a sorting hat that can peek into the mind and brain of a learner and find the best environment for them to succeed in. So when I started trying to figure out what we know about programming languages, I found this study by Quill and Bergen, where they studied 700 students in CS classrooms and were able to predict with up to 71% accuracy who would succeed as they learned 6 different languages. I sort of thought the problem was solved until I looked at what they used to predict learning. I think we can summarize the challenges or the limits in this study in 3 ways. First is that they're only looking at people who have already self-selected into computer science classes. Second is that the best predictor of learning to program was a measure called programming self-efficacy. And this is really about your confidence or how well they estimated they would do. And the best predictor of programming self-efficacy is previous experience. So here we just see a Matthew effect, the rich get richer and the poor get poorer. And the third thing is that there isn't a cognitive model underlying what they selected to try and understand programming. So there's no clear theory about why they looked at math exam scores and not language exam scores, or number of hours spent gaming and not number of hours spent reading. If we're going to change programming instruction to match the learners, we need to understand why. Okay, so to some people, this might be a kind of weird idea. You think of language as a social communication tool, but language is also the most powerful symbolic system we have for thinking and communicating complex ideas. And fortunately, we have 50+ years of research looking at what makes language learning hard in the classroom and who is going to be successful. In my lab, we've been developing resting state brain measures that predict who will be successful second language learners and in what context. And in 2016, we showed that if you decompose resting state encephalography into characteristic neural rhythms, you can predict with up to 70% accuracy how quickly someone will learn French through software that are pretty similar to what we use for learning to program in Python. So here's what we did. We brought people into the lab and we measured their brain networks at rest using fMRI and EEG. Then we gave them standardized language aptitude and numeracy tests, as well as a battery of cognitive measures like fluid intelligence and executive functioning. And then we taught them Python in 10 sessions of Codecademy. We recorded 3 learning outcomes that included learning rate. So here you can see each learner in a different color. How quickly did they move through the Codecademy sessions across their 10 trainings? The fastest learner learned 3 times as quickly as the slowest learner. We give them a multiple choice test afterwards that asked them to recall knowledge they had acquired or to recognize it. And then we gave them a programming exercise in Codecademy. In short, what we found is highlighted here. So the pink part of these bars represents language aptitude as a predictor. The bar on the left, I can't actually see it because of my Zoom screen, is learning rate. Learning rate was predicted, 30% of the variance was predicted by language aptitude, programming accuracy a little bit, and none of the post-test. What you see in blue here is the numeracy measure. So numeracy predicted very little of the outcome and learning rate, none of programming accuracy or declarative knowledge. And the beige measure is our measure of neuropsychometrics. So our previous predictors of language learning also predicted learning to program. The moral of the story is just that I think second language learning is a decent model for beginning to understand the neural and cognitive bases of learning to program, at least in Python and at least for the early stages. And we're working on figuring out the rest later. Thank you so much for listening.